Okay, normal distributions. You have to know the z-score formula. Z equals x minus the mean over the standard deviation. Standardized test statistic, that is on the formula sheet. Here, we'll click over to the formula sheet. You can look, that is on our formula sheet, but it's the statistic is your x, the parameter is your mean, the standard error is the standard deviation. But it can vary, for instance, if we're using proportions and things like that, then we would use this standard deviation formula. But some of those, we'll go through those a little bit when we do some of the other videos. But for on here, our basic formula, this is basic normal distributions. So we're just going to jump into number 10. We've got a couple of old multiple choice questions. The length of individual shellfish in a population of 10,000 shellfish are approximately normal. As soon as you hear something is approximately normal, they give you a mean and a standard deviation. You should know, hey, I'm doing a normal curve problem. And this one is a little bit different because it's got a little bit of extra thinking that we have to do. It says, which of the following is the shortest interval? That's going to be key to the problem that contains approximately 4,000 shellfish. Now, it's 4,000 shellfish out of 10,000, which if you divide that out, that's 40%. Okay, so we're looking for a distance that contains 40%. Okay, so right away, if you're looking for an area, you take these numbers 0 to 9.949. You should use your normal CDF function. Okay, if you are using the Inspire, it's menu 6.5. I can't remember on the TI-84 anymore. I don't teach on that one. So hopefully if you've been using that one all year, you're familiar. Number 2, but on that one, you should have a lower boundary and an upper boundary. We've got 0 as our lower. Our upper is 9.949. It's a CDF, cumulative density function, cumulative area. And then the mean is 10, the standard deviation is 0.2, and we're looking for that area. And that area says it's about 40%. It's 39.93. So that could be the answer, but this is where this is going to come in. What's the shortest interval? If I were to draw this on the curve, one thing I want you to realize, the shortest you are going to be able to find 40% would be from a value below the mean to a value above the mean. That's not what we have here. We're going from 0, which is way down here, to 9.949, which is up here. And that's quite wide. I would almost guarantee that if I were taking the test, I'd just cross that one out, knowing that some of these other ones are going to be 40% as well. If we do part B, and we do this one, and we go menu 6.5, we do number 2, 9.744 to 10, mean is 10 and standard deviation is 0.2, and we find that area, that's also about 40%. And that's a lot shorter because the first one, we take 9.949 and we subtract 0. We're looking at the distance away. That's 9 units difference. And this one is a lot shorter. It is 9.744, so it is 0.256 wide.
Please report to student services.
It is 0.256 wide. Sorry, come on with the announcements. I thought they were done for today, but I'm going to keep going with this one. So that is 0.256. That's a lot shorter. Okay, now the next one, if I'm looking at the next one, it starts with the same number, but it goes wider. So this one, actually, I know this one, if I understand that that one's 40%, this one's going to be 80%. It's going to be way wider. You can test it, but it's exactly the same distance above the mean as it was below. So this is a much wider interval. It's got to contain more area. And if we do part D, that one's 9.895 to 10.105. And that one is 40%. That one, if we subtract them, 10.105 minus 9.895, that one's a lot shorter, 0.21 shorter. That one ends up being the answer is D. E is only going to get you 30%. Just for the sake of time, I'm not going to do E. I would check them all. Okay, now this one, normal CDF, a couple of key points that I'm going to type on here that you should write down. Normal CDF is used to find area. That's what we did. Okay, and you have a lower boundary and an upper boundary. Inverse norm is used to find values or z-scores, and you start with an area. So a couple things to keep in mind, okay? Because as we do this next one, it says the distributions of diameters of a particular variety of orange is approximately normal, okay? Normal with a standard deviation of 0.3. How does the diameter of an orange at the 67th percentile compare? So one more note I want to put down somewhere on the page. A percentile is the area to the left. So you have to understand, if we have 67% of this curve, we know if we draw a line here at 0, 50% of the curve would be below 0. So to get 67% as the percentile, we're going to have to be above the mean. With that, we can cross off A and B because those are values below the mean, so one of the other ones is right. Now, I made this value 0. We don't know the mean. If you don't know the mean and you're using an inverse norm, you can have a little bit of intuition. We're going to go menu 653 here, the inverse norm. Remember, the area you put in inverse norm always is the area to the left. Now, on the 84, there's some other ways you can do this. We're not going to focus on those, but I'm going to put this mean as 0 and the standard deviation 0.3. We don't know the mean, just to be clear. But what we get is 0.132 if we round it. So it would be 0.132 about above the mean. If I had used a different value for the mean, let's try it. Like say 20, I would have gotten 20.132. It still would have been 0.132 above the mean. Okay. There's other ways we could do that. We could do it, find the z-score, fill in the z-score, do it a little more algebraically. I just think that's kind of the easiest way to figure that one out. First of all, the drawing gets you down to 3 answers. Remember, drawing a curve, you can draw on your AP test. The only thing that's going to count on these is what you bubble in. All right, so number 3. I had to redo this video because I messed up number 3, I think almost entirely on my other videos, so that's why I'm redoing this one. Hopefully I get it right this time. Men's shirt sizes are determined by the neck sizes. They're approximately normal. They have a mean of 15.7, standard deviation of 0.7. Okay, so a couple things. I'm going to do part A, kind of in this whole area up here. We'll get B and C done down there. But a retailer sells shirts in sizes small, medium, XL. The sizes range from 14 to 18. So if I draw this and I make this 15.7, I add 0.7, I get 16.4, 17.1, 17.8, and go this way, we get 15, 15.3, 13.6. We're going from 14 to 18. That's the shirt sizes. So 14 would be down here. 18 is a little bit above the third standard deviation. That's the area you want. Okay, when I teach this, I always tell students there's 4 things you want to get on there. You want to get the curve shaded, and then you want the 2 z-scores. There's an optional way not to do the z-scores. I will go through that, but I will do the z-scores on this one. We'll take 18 minus 15.7, divide by 0.7. Okay, so that should be 3.28, I believe, as a z-score. The other z-score is 14 minus 15.7, divide by 0.7. And that's 2.43, but it's negative. Okay, so to find the area, a couple ways we can get the area. I'm going to clean up my calculator page here. We're going to go menu 652. We're looking for an area. So negative 2.43 is my lower z-score. Positive 3.28 is my upper z-score. If you do this, you can leave your mean and standard deviations 0 and 1. Hopefully this is ringing a bell. I don't go through it like we're learning this for the first time. This should be review. This should be familiar. Those are z-scores. So you leave the middle z-score 0, the top z-score 1, and we should get 0.992. Now, the other way we could do this, of course, is to do the normal CDF. And we can put in the values, 14 to 18, put in the 15.7 and the standard deviation 0.7. Should get the same thing, 0.992. Okay, so if you do that, these two z-scores, you could, I'm going to write this up here, you could do a normal CDF, 14, 18, 15.7, comma 0.7. But if you're going to get that counted as work on the AP exam, you have to label those things. You have to label this is your lower bound, this is your upper bound, this is your mean, this is your standard deviation. If you say, how do I remember that? Well, as long as your calculator is the same calculator as on mine, when you go menu 652, all those things are on the screen. So use the screen to help you remember. This is not like AP Calc. AP Calc, 40% of the test is without calculator. Ours is 100% with the calculator. So use the calculator to your advantage. The same thing, if you can't remember a name of like a hypothesis test, one prop Z test, you're like, I can't remember the name. There's just no excuse, because you can go menu 6, 7, and you see number 5 is the one prop Z test. Use those names. Yeah, the chi-squared, you have to remember for this one, it's homogeneity or independence. If you're doing the paired t-test, you can't just say t-test. There's a couple of those that doesn't help you on. Those 3 is it. The rest of them, they're all on there. Okay, so now you get this. And the last 2 points that I always graded, 99.2% chance you have one of these sizes. You need the context. So the shirts in those range from 14 to 18, that's 99% chance. All right, B, using a sketch of a normal curve. All right, let's do that. Let's put in a 15.7 and illustrate the proportion whose shirt size is medium. So one of the main things, the accuracy isn't always the big thing. It's the idea at 15 to 16 would be surrounding the mean. It would be going in there. This one I'm going to do it the kind of the cheater way. Normal CDF, we're going to go 15 and call that the lower bound. 16, call it the upper bound. 15.7, call that the mean. And 0.7, call that the standard deviation. And we'll see what we get with that. Sorry, can't see. Hitting the wrong button. I'm hitting delete. Menu 652. It's my lower bound 15, 16, 15.7, the standard deviation 0.7, 50.7%. .7% chance of a median. Okay, now whatever we got for B, okay, I'm going to have to erase that so I have a little bit more room to do this one. But we got 50.7. I know I messed this up on the other video. Hopefully you're taking the time to rewatch this just to check your answer. If you don't, that's fine. But whatever you got here, if you do mess up on a part on the AP test and you got a different answer, as long as you use it correctly for the next part, you can still get that answer right. So that's one of the nice things, because C is relying on your answer from B. Well, what if you don't know how to do a part? Okay, so every student should listen to this part. If you don't know how to do a part on the AP test, then take a guess if you need it for the next one. 50 would be a nice, neat guess. But this one now, this one is a binomial question. We will review binomial later, but the binomial formula is this one. Probability, I'll circle it on here. That one right there. So if you have your formula sheet, I recommend when you're going through these reviews, you have a formula sheet so you can look at it. You need to know how to fill that in. Okay, now that is a binomial PDF, okay, but we'll fill this in. Probability x equals 4, exactly 4 mediums. You're drawing 12 mediums with 4. How do I know it's binomial? They're giving me a certain number of draws. We've got a success-failure situation. It's either a medium or it's not. We've got a probability given of 50.7 from the prior problem, 0.507, and we've got a independent situation. That's the SIP that we talked about, plus the criteria for binomial is that it's a certain number of draws. Now we take 507 to the 4 times 493 to the 8. Now again, if you're in my face-to-face classes, we do this one just a touch differently, but we're going to go menu 6.5. It's a binomial PDF, 12 trials. I'm going to do it both ways, 0.507, exactly 4. In my face-to-face classes, I've kind of quit teaching the PDFs. If you're in my online class, I haven't redone some of those videos the way I do it. It doesn't matter. PDFs and CDFs, the answer is 11.4. I'm going to show my online students this one, menu 6.5, B. We're going to go to the binomial CDF. You can use a binomial CDF or a geometric CDF every time. Here's the way you would use it. This is 12. This is 0.507. My lower bound is 4 and my upper bound is 4. If you put the same number, it's still only going to do exactly 4. Now, that answer is 11.4. With this one, you can do either binomial PDF. I'm going to do it as a CDF. 12, 0.507, 4, 4. My recommendation, if you use the CDF every time, you label these, this is N, this is P, and then you say, this is my lower and upper, and they're the same. Okay. Same number, meaning it has to be just 4. There's no other options, and we get 0.11 for chance of 4 mediums. Now, every single open response question, free response question, put context on every single one. Okay, next one. Trains carry this bauxite ore to Canada Aluminum Processing. They've got a mean, they've got a standard deviation. They're telling us it's normal. I'm going a little fast. Pause the video so you can read a little bit more. But part A, if the filling is functioning properly, what is the probability? The weight is 70.7 tons or more. So I'm going to do part A up here. It says it's normal. Remember to always look for that. We'll talk about that in the last one on the sports teams. But our mean is 70 tons. We're looking at 70.7 or more. One of the things I always use is, if you've got money on you and somebody says, do you have $5? Well, if in your wallet or whatever you carry your money in, you've got $10, you can say yes. Because if you have 5? Yes. If you have 10, but if you have 4, you can't say yes. You don't have 5. It has to be greater. This one is clear that it's greater, but just make that point. Okay, we've got a curve, our z-score. I'm going to do this one the old school way. We're going to go 70.7 minus 70 over 0.9, got a lot of decimals in there, so it is going to make it a decimal. The Inspire calculator is pretty cool. If you do the control divide feature, 70.7 minus 70 over 0.9, it looks exactly like the z-score, but we get a 0.777 z-score. So I'll write that down in a minute, but I'll use this, menu 652. We're looking for an area. So I'll even keep it really accurate. We'll put a lot of sevens since it was the repeating 7. We get 0.2183. Now I could have done this way, menu 652. We could have gone the 70.7 to infinity. 70 is the mean, standard deviation 0.9. We still would have got the 2183. So our z-score 0.777. 21.8% chance it's over. All right, B, suppose the weight of the ore is 70.7. So this is the part why I brought up the wallet. It is 70.7. Well, if it's 70.8, it is 70.7. If it's 70.6, it isn't. So it's saying it's 70.7 or more. Would that make you suspect the loading system is overfilling? We got a 21% chance. This is really a p-value question. That's greater than 5%. So no, this isn't rare. We're not going to reject the null, even though we didn't write a null, but it doesn't make me suspicious. It's just random fluctuation. Okay, now I don't always write everything. Remember, you'd explain this isn't that rare. So make sure on the AP test you get that idea that it's bigger than your standard alpha, your criteria. So I don't think it's that rare. I wouldn't be that worried. All right, number 1. Now, this question, nowhere in the problem does it say it's normal. Now, actually in number 1A, it's going to ask, do you think it's normal? Well, how do I know that? Okay, so a professional sports team evaluates potential players for a certain position based on 2 main characteristics, speed and strength. Speed is measured by the time required to run a distance of 40 yards, with smaller times indicating more desirable, faster speeds. From previous speed data for all players in their position, the times to run 40 yards is 4.6 seconds as the mean and standard deviation 0.15 with minimum time of 4.4 as shown as a table. Based on the relationship, is it reasonable to believe the distribution is approximately normal? Okay, so let's find the z-score. Remember, it doesn't say it's normal. We're figuring out if it's normal. But our z-score would be 4.4 minus 4.6. Always subtract the mean. Remember, you always subtract the mean. Whether you're doing residuals, you subtract y hat, because that's the mean, or you're subtracting this, and you divide by 0.15, it gets us a negative 1.33 z-score. Okay, so how can I tell if it's normal from that? Here's the reason. On any z-score, we kind of expect the data to be between -3 and +3. We're only at negative 1.33 is the lowest value. So that sure doesn't seem normal if we're going from that negative 1.33 up. You can get people to run slower, but it's harder to run faster. And that's only negative 1.33. It's not 3 standard deviations away. So this one, I'm going to give you this into words. I'm not going to write it. I wouldn't think the distribution is normal. I'd expect it skewed right because the minimum isn't that far below the mean. It's only about a little over 1 standard deviation away. And it would be easier to run slower times. That's what you need to explain. Okay, now the last one is just a basic z-score question. It says strength is measured in the amount of weight lifted. Okay, we've got a mean of 310, standard deviation of 25. We have a person who lifts 370 pounds, I think. I don't know where it's at. Yep, there we go. Well, they're at 2 point something. So let's do their z-score. Remember, always subtract the mean. Okay, how do I interpret this? The weightlifter had a lift 2.4 standard deviations above the mean. Remember what a z-score does? It calculates the standard deviations you are above the mean. It doesn't need to be normally distributed. I know I drew a normal curve. You cannot calculate with this one since we don't know it's normal. You can't calculate percentages, but you can definitely say that that person was 2.4 standard deviations above the mean. Hopefully that helps. I don't think I made any errors this time. Thanks for watching.